Oh, what's up, what's up, what's up, what's up? Welcome back. Today we're working on my diff tool slash git GUI. So the idea is I'm writing this git GUI for reasons I'm not going to go into right now. But one of the things it does is it like shows diffs when I click on commits. So I look at a commit and I say like, oh, here's what changed between that commit or the commit before and this one. And we're kind of in this case right now where we've implemented like this really shitty version, or I shouldn't say shitty, a naive version of this like Myers diff algorithm, which is, as far as I can tell, the algorithm that everyone uses generally. Like git diff is using Myers diff. It's and basically what it's doing is it's constructing the diff in a way where it turns into like a 2D graph traversal problem, and then it kind of intelligently walks this 2D grid. So maybe I can give an example real quick. So here we have a source string along the top of the UI here, and a destination string along the side. And the idea is if I want to go from, well, these are too long. Let me try something a little shorter. So say we want to go from like 1, 2, 3, 4 to 1, 2, 4, 3. This can be represented this way, and the idea is if we go 1, 2, 3, 4, maybe I'll draw it like this, and then we try to go to 1, 2, 4, 3. If we start with 1, 2, 3, 4, we can say like, okay, well 1, 2, that's the same. 3 is no longer the same, so we'll delete that, and then we have 1, 2, 4, and we add a 3 at the end. So that's represented here by saying, on this graph, if we do a rightwards move, that's a deletion from the first string. If we do a downwards move, it's an addition from the second string. And any diagonals on here are like these two things were in common, and so we can just kind of move forward. So if we like run our algorithm, we see like he tries to shoot down this diagonal as fast as he can because he sees like 1s and 2s, they line up. And then he kind of branches both directions and gets to the end in some way. So he decided that he wants to take the 1 and 2, delete the 3, take the 4, add the 3 again, which is exactly what we did by hand. The problem with this is once we start getting into like bigger problems, we have to walk a large distance, which is like maybe fine, but the real problem is that the memory usage that we have to use to do this is like quite large, right? Because until we get to the end, we don't know which of these like branches in our tree are going to take up the like least, which one's going to win. And so we have to remember the path that every single branch is taking, and that's like quite expensive. So where we're at right now is we can kind of do the same thing, but we can run it in this like memoryless mode, and we can run it both backwards and forwards at the same time. So hold on, we have to set max memory. So the idea is we go like forwards and backwards at the same time, and at some point the like forwards and backwards passes like collide with each other, and we have like this now new point where we can do it again. We say like which one of these is using more memory, we run it again, we keep going until we get to the point where we're below some memory threshold that we've like set by hand right now, and then we do like the slow walk again. But now the like total number of branches has reduced drastically, and so we have to remember a lot less. Perfect. And so that's where we're at right now. And what we want to work on today is we're just trying to like really like drive this to the end. So try to figure out what's missing in order to like call this done. And the biggest thing right now is if we set the memory limit too low, we can easily get into a situation where it fails to reduce the size of any box. And what it starts doing here is it just keeps trying over and over and over again. And so this is a bug, right? This shouldn't happen. So I think first thing to do is fix that. And then hopefully that's the last thing. I'm not really sure what else is broken right now. But then once we fix that, then we can like integrate this with our Git GUI, test it a little bit more thoroughly, and see if there's any like edge cases we've missed. And we've left like kind of like a wake of destruction over the past few streams. So if we get too far too quickly, we can just spend the rest of the time like cleaning it up and making it presentable and committable and whatever. Yeah, that's the plan. That's the plan. So I think we can just start looking at how do we stop this edge case? How do we stop this edge case? And I suspect I suspect that it's related to like how we choose the intersection point. So here we go bump, 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 bump. Fuck. I'm trying to stop at 1 before. So I think it's here. So what's going to happen is these guys are going to all branch down on the yellow side. And the orange side is going to branch up to the left. And this guy's going to hit some diagonal. And I think they're going to intersect around here somewhere. And I think we pick the rightmost intersection point. So like if orange and yellow kind of like overshoot each other, which they do because they're both moving at the same time, we might end up in a case where we have to pick which side of the intersection to pick. Like where along this intersection line do we want? And I think we're picking the rightmost side. And I think that if we pick the leftmost side, it might work better. I'm not sure about that, but I think it's worth trying. Let's see if we can figure out where this is going to intersect. So I think probably this is going to come here. Then he's going to shoot down to here. This guy's going to come here. This guy's going to come here. I don't actually know where this like intersection is happening. Let's look again. It's right here. So why? What am I missing that's causing that to trigger? It's because it's happening faster than I would have thought. It must be this one comes down, goes to here. But how is orange making it there in one step? I'm missing something. It feels like it shouldn't be getting there in time. Okay, I'm going to screenshot this. Screenshot. Because I feel like I'm missing something obvious here. So yeah, he did go to this point. Right here. How? How? Am I high? This comes up to here. This comes right to here. This comes... I don't see how orange is making it here at all. Which feels like a bug, but I guess we can look closer and find out. Okay, let's look at like this like intersection picking code, whatever we want to call it. So this is in lib diff, and we call it like snake state, I think. Because in the paper they call this like concept of looking for these like intersection points snaking. Am I high? Where is this code? Linear diff. Okay. Snaking state response. Here we go. Snaking state. Here we go. And so here he's saying, here is my forwards X position. Here's my backwards X position, and then we compare them. And I wanted to try picking the backwards X instead of the forwards X. So somewhere we call this meeting point. And I think we can just say backwards X val for here and here. And I think that that should end up result like slightly different behavior. So let's just kind of see what that does. So that's the same, that's the same. Okay, so we are making it farther than we were before. Before it gave up much earlier than this. So it does look like the idea of reducing, like picking the top left is better. We do end up with this clear path. But we still do end up in this like edge case where we just keep making new boxes and we fail to shrink them at all. So we kind of need to like detect that edge case, I guess. So we could do something like what does this guy do? So he says, hey, here is what happened. And I said, hey, I finished snaking. But he probably hasn't finished snaking. So it's probably this area he's kind of like constructing the new forwards and backwards algorithms with their like new region of interest. And I guess before he does that, he has to check, hey, is my box the same fucking box? Because if they are, then fuck off. So maybe we could say, if meeting point where these two forwards and backwards passes collide with each other, if this is the same as the bottom right of the box, like this. So this is going to be the bottom right. So this is right and bottom. Self ROIs, self current index, bottom. So if these are the same, then we have to return something that's like no more minimal memory. Cannot, maybe we'll say that we're finished. We can say, hey, we are finished here. And the caller can say, am I going to exceed my memory usage? So here he's going to say, no, he's already done the calculation, so he should know. So maybe we'll say, no more options or something. Do I even want to change behavior here? I guess I probably do. I probably do. Yeah, I'm okay with that. So here's going to say no more options, but these are all of my meeting points, and we can decide externally what we want to do with that info. And we could either say, fuck it, let's just do it. Or we could return an error. Returning an error, probably... Does that make sense? Do we ever want to fail? Maybe not. Maybe what we'll do instead is we'll consider this like maximum memory usage like a suggestion. I kind of like that. Yeah. So let's just say here, maximum memory usage is just a suggestion. Smiley face. So if they say, don't go over this and we do it anyways, fuck them. Because the max memory usage also like is only we're only limiting one of the many actions. So, and it's the most expensive by a long shot. So I think that's probably fair. Maybe, I mean, if they say like, if they give us a limit of like 1,000 megabytes, like a gig, and we're still going over, maybe that's problematic. But maybe it's fine. Maybe it's fine. So now we should be able to run this same thing, and we should get to the point where we've hit every single box as small as it can go. Like this. And now it should detect that case where it tries to shrink a box, and it can't. But it's not it doesn't look like it's detecting that case correctly. So maybe we can print line here. Meeting point. Oh, we were already printing that. And are we printing our current region of interest? Current ROI is going to be the current IDX. And let's just see if we've just made a slight mistake here. Possible slight mistake. Okay. Bump, 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 bump. Oh, interesting. So here he's saying that the meeting point is 3.6, but the current ROI ends at 3.47. So 1, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Right, so it's meeting down here. This is probably one of the boxes right here. Right. Right. So what's ending up happening is the meeting point is 3, 6. And what box are we inserting in there then? Then we're putting somewhere. Aha. 3, 6. Top 6, 3. So here we're getting top left is equal to bottom right over and over again, and we're injecting that over and over again, which is not helpful. So maybe that's like another edge case that we have to check. So we can say, or so we kind of want to do like if the meeting point is this, or the new forwards ROI width is equal to 0, and its height is equal to 0. And I guess we have to do the same check for the backwards one. Okay. Fix me ugly condition. We're going to come back to this, but for now I just want to see if that actually does it. So here glides, boom, 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 boom. Shrink. Oh, there we go. Yeah, so we successfully exited now, and now we're just kind of womp. Oh, there's a bug here too. This diagonal should always be taken. Interesting. So we've actually, yeah, all of these guys are no longer taking the diagonals that they should. So we're actually like over shrinking, which is interesting. So where's that happening? Oh, whoa. Okay, so here, these guys shrink. Okay, that's fine. Also fine. And then, oh, it's not here yet. Okay, so here, what happens here? How is this a meeting point? There's a bug. We're picking the wrong spot. These do not meet here. Yeah. There's a bug. Holy, I can't believe I didn't notice that earlier. Okay. So these guys should select like here or here or something. I don't understand. This is crazy to me. So we have forwards x3, backwards x1, which was... Can we get back into that state? I want to look at it again. This one. Okay. So I want to screenshot this, I guess. Nope. That's not helpful. I guess copy-paste isn't working. That's cool. Love that. Okay, so we have this. And so I hit next, and let's look at what it says. So here you said the forwards x was 3 where they met. 0, 1, 2, 3. And the backwards x was 1. So 0, 1, 0, 1? Yeah, so 1 seems crazy to me. Let's think about this. What does backwards x1 even mean? So backwards x is supposed to be on this diagonal. Oops. What did I just do? No, no, I don't want this. How do I undo it? Okay, there we go. Whew. On, I don't want black either. Can we draw on like, I don't know what color is unused, red? On like this diagonal? No, it's not that diagonal. I guess it's probably this diagonal. The forwards K value was 3, which makes sense. 0, 1, 2, 3. But the backwards X value being 1 feels odd to me. Because the backwards X value should be also 3. They meet in the same spot? So he's saying, hey, at my forwards D value and this K value, I guess this is kind of invalid. That could be it. So the way that this stuff is represented is we draw this like, hello, why can't I draw? Dude, I'm gonna lose my fucking mind. I'm not doing anything that should make this a drag. Oh, it's because this isn't expanded. There we go. Okay. So the way this is represented is you have like this like tree of decisions. So at each branch, he's going either left or right. And so D is supposed to be like this direction. So this is D0, 1, 2. And then we have like K in this direction. Where on this graph that we were seeing before, this would be like D is this way and K is this way. And so this should be K0, -1, 1, -2, 0, and 2. And so the DK is like, we index into this like linear buffer. And we kind of say like, this is D0, K0. Then we go like, okay, so that's row 1, done. Row 2 is D1, K -1. And then we have like 1, 1 here. And then we go to the next row. 2, -2, 2, 0, 2, 2. And I think what I'm seeing is when these guys are like unaligned, we're indexing into the backwards one with like a DK combination that's like not valid. And so we might be accessing some memory that we don't expect to access. Because here, this is like K value 1 going forwards. Oopsies. K value 1 going forwards, but it's K0 going backwards. And we're looking at depth value for the forwards version. So here we're looking at like D1, K1, but we're looking at maybe like D1, K0 on the backwards pass, I think, maybe. So maybe what we should do here is do some like assert that D% 2 is equal to K% 2. So that should make sure that we're always matching our evens and odds. And maybe we have to like absolute value them. I think. We can try that. And that might give us a clue here. Yeah. Yeah, we're definitely hitting that. Okay. So what we should do is if they're mismatched, we need to index with like one earlier D value. So we can say like if, where was that assertion we just added? This. So we can do something like if, I guess we'll do like is even. That seems reasonable. function is even. And we take in a value, and he's 964, and he returns a bool. And we say x%2. I don't know. Does modulo operator... How does like modulo interact with negative? I actually don't know. Can I just go to like Rust Playground? So you have like print line -2% 2. What does this do? That's 0. -1% 2 is -1. Yeah. So we just kind of want to say it's even if it's not, if it's equal to 0. Like this. Actually, maybe is there already like an even thing? Depends on the programming language. I've had some fun with that a while ago. That's fair. I could see it doing different things in different languages. That doesn't surprise me. So how we can do something like let backwards x val is equal to if is even self the d value is not equal to the is even backwards k, we need to use d minus 1. Else we do whatever we were doing before. Ugh. This is awful, but we can deal with it for now. Okay. Let's see if that behaves more sanely. We can see. Okay, that's promising. Okay, so what was happening before? We were seeing like incorrect diagonal matching. What happened here? Over memory limit error. Ooh, that's interesting. So I think what happened there is it does look like, remember at the beginning of the stream, I was like, how the fuck are they meeting at this point? It does look like this fixed that problem, because here we're seeing that we go one more step here, and that makes way more fucking sense to me, right? So now they're definitely going to collide, and we should pick what, like this? No, we pick here. Why do we pick there? Oh, because we iterate down to the left. And so we hit this connection first. Sure. And so I think what's happening now is we're hitting like the end case way earlier where we can't actually reduce the distance anymore. Right here, I think. This is the last box that we can actually reduce memory usage. No, one more. Maybe this one. This one should be able to shrink. But he's, oh, I see. So he's saying, so he tries to shrink that box in the top left. He tries, and he fails, because when these guys collide, they collide at the bottom right. And then they say like, well, this box didn't shrink. And so then we exit early saying, well, we can't shrink it anymore. We must be done. Oh, but that's actually not true, because this box over here can definitely be shrunk more. So there's something there about like we should mark a box as complete, or there's something about like maybe we should be extracting these diagonals out, right? So maybe instead of defining one meeting point, we define a meeting connection or something. So maybe we like end one box here and start the next box here instead of having them overlap. But also, this doesn't have to be perfect, probably as well. We might be able to just get away with this behavior. Yeah, we could do that. And so maybe when this guy finishes, we construct our forwards version. And instead of using maximum memory here, we're going to use usize max. And we're just going to put a little comment here. Maybe we'll say const max mem usage is a usize equal to usize max. A tool for diffing what? We're trying to work on this. Get dt origin master. This is bad. Spit. Maybe this is a better example. Here we go. So here in our Git GUI, we have like diffing for files, but it can diff whatever we want it to, right? The algorithm will work on anything that's equality comparable, but we're using it to generate diffs for our Git GUI. So here I'm just gonna put a comment here saying, note that at this point, we've done our best to reduce memory usage. If we are still over the requested limit, we treat it as a suggestion and continue on. Okay. And then here we say max mem usage here and here. Okay. So now, let's see what happens. Okay, boom, 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 boom. Okay, you know what? That seems pretty reasonable. This diff does seem like it's no longer like degrading to the point where it's picking the wrong path. We're seeing the diagonals that we want selected. How much memory did it end up using? It ended up using 800 bytes when we requested 50. Maybe that's fine. Looks like it's diffing a matrix in this window. Well, I mean, this is like a visualization of how the algorithm is running. So this like grid is like the path that we are walking in order to generate the diff. So I think that looks pretty good. I think that there's like a to-do in here to reduce memory usage further, because we know that like it could go further. I know it could go further based off of like these diagonals, or anytime there's like a big diagonal, we allocate actually a big chunk of memory. Oh, fuck. This actually might not be good enough. Oh, fuck. Because say you have like a really, really, really big ass file and it's got like almost everything in common. We're going to kind of try to reduce, and we're going to end up with one giant ass box that's still going to try to allocate a fuck ton of memory. So we actually do have to take this farther. Fuck. Oh, okay, so what is like the solution to that? The solution is that our meeting, we should like somehow... Is the algorithm typically traditionally not linear? Have you made it linear? So this is like a version. I think this like exists. Like the paper for Meyer's diff suggests this, and like the blog posts I was reading on the topic also talked about this. So we're not doing anything new. We're just discovering how it works for ourselves. And I don't really know their implementations in detail. Okay. So I think the trick here is we need to define our meeting points as 2 points. I think. Why do we care about memory allocation? Just buy more memory for or whatever, right? I mean, I was at the point where it was trying to allocate like a terabyte of RAM for like something that was just in my working directory. Just like, that's unreasonable. Okay, so if let's maybe run this again. And let's just kind of screenshot this area here and use this as our example. So say say we're currently working with this box. And we're drawing around the whole thing. What we want to see is we want to see somehow like this node and this node get selected. They like collide here, right? That's kind of what we saw, is they collide here. And so he's picking like this bottom right. But we kind of want to store like something about this connection in some way. So we kind of want like a box drawn like here and then another one drawn here. And then when we get to this point, we kind of want like, this is where it gets like tricky, is we want on a diagonal, we want it to end up in the case where it says, okay, I know that I can go here and here. And so we kind of want to say like, we want to encode that there's this diagonal kind of like externally somehow. So we don't have to like allocate this big box, we just allocate the box for everything but the diagonals. So what's the play here? I guess we could think and use our brains, or we could just start blindly typing and see what happens in the visualization. And maybe that's kind of the path forward, because I like, it's easy to get stuck just like looking at the same thing over and over again, and I feel like I'm not making progress. So I feel like maybe trying something and seeing how it pops up in our visualizer might help. This diffing algo will produce better git diffs. No, I don't think so. But the benefit of doing it all this way is, one, I get like a better understanding of what it's doing, and two, I have like more control. So like an example is, maybe this isn't true anymore, but when I first wrote this thing, I wanted to replace my workflow of going git review origin master, which is basically doing like an inline diff. But one of the things that like git diff does that is like super fucking sick is there's this like git diff color moved origin master, and maybe there's not really a great example in here, but like it noticed in this example that like there's a moved section here, and I was like, why do like none of the diff tools I use have this feature? And so now that I like have control, I can write a diff tool that does that myself. Let's see if I think there's an example of in here somewhere. Maybe because with white space tracking off, it's easy to find. Really? Where? I'm sure that there is one in here. Oh yeah, here we go. Right, so now in my diff tool, I have like that same behavior where I have like diff movement tracking, which is pretty sick. And like there are like other things that I want to try. Like I know that a syntax-aware diff tool would be way fucking better. I just know that that's true. Right, because there are like times where you see stuff like this, and it's like, what the fuck are you, oh, that's not a bad example, actually. That one's not too bad. But there are cases where you see this just like shit show of things, and I suspect that if I somehow managed to hook into like tree setter or something, then I would be able to do something better. And so like having like the whole stack gives me like one, better intuition and better control. In reality, if I were to write a diff tool for like real production, would I implement the diff myself? Maybe not, but it helps me understand. And that's really the more fun part, is we're here for partially to make something that's useful to me, but more just because I think it's fun. Anyways, distracted. Wow, hooking into tree sitter sounds interesting. Yeah, I was kind of disappointed. I saw on Hacker News the other day that like this exists. For those who don't already know, this is built on tree sitter. I'm like, fuck, they beat me to it. But I'm still probably going to try it at some point. But like, this seems pretty fucking sick, where like they have the same idea and they have like some form of like love from the internet. They're saying like, yeah, fucking course that's better. And it's like, yeah, of course that's better. Like, yeah. Okay. So what was I doing? I was trying to figure out how to structure this so that large diagonals don't end up causing large memory usage. So let's call that a new section. So here we're trying to prevent large memory usage from large diagonal. Okay. Structured editing with tree sitter is nice too. What's structured editing? Structured editing. Tree sitter. Structured movement and editing with tree sitter. Is this what you're talking about? So they like, oh, so like maybe for like refactoring tools. What the fuck is happening here? Oh, that's pretty interesting. Okay. Oh, that's super sick. Yeah. So like auto closing tags and stuff. I mean, to be fair, I'm not like the biggest fan of like my editor doing too much for me. Like I kind of like, it pisses me off because it never works quite right for me. But I can see a world where this is very, very desirable. That's pretty cool. That's pretty cool. Okay. What was I doing? Figuring out that diagonal shit. Okay. So I guess what we should try is when the forwards and backwards values pass each other. Well, first, actually, let's do a little smiley face commit just so that we have a checkpoint. Obviously, I'll clean that up in the future. But we should probably do something like when they collide, they must have collided by one movement, right? Because they're moving forwards and backwards in lockstep. I think. Maybe not, but I think so, right? So they kind of go bump, 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 bump. And we know that here, what's going to happen? This guy's going to move to the right, and this guy's going to move to the left. Orange is going to move left and end up here. Yellow is going to move right and end up here. And so we can kind of say, well, we'll just store both points. And we'll infer that there is a valid connection between them. So I wonder how that works in the case of a diagonal. Because, like, the way that the algorithm works is if you have, like, I don't know, something like this, where there's, like, a connection here and a connection here, and we're, like, I don't know, here. What's going to happen is he's going to, say we start here, he's going to step to the right, and then immediately step down to here. So there's kind of this like kinked movement, but it goes like right then down. And so say, let's just like draw out the case where we're going forwards and backwards, and we've kind of got like this scenario. So we've got the backwards guy and the forwards guy, and they're about to smack into each other, right? This guy, we are here and here. And then we're going to end up, state 2 is going to be like here from the forwards pass and here from the backwards pass. Okay, that's a fine scenario. Because in that scenario, if we were to just draw a straight line between these 2 points, everything's happy. What if they don't start like that? What if they start, say we start on the backwards pass from one further away. He's going to hit here and here at the same time, and then they're going to cross here. Okay, I think that's maybe okay, actually. Maybe if we just store the forwards and backwards positions, maybe there's always a reasonable direct connection between them. Maybe. Just from this one simple case that I drew out, it feels like that's true. I don't have any proof, but it feels that way. So let's try that. Let's just try splitting it up that way. So the idea is going to be when we split up our box, we have meeting point. Fuck meeting point. We're going to have meeting points. So we have forwards xval and a backwards xval already. Our new backwards ROI and forwards ROI, like the boxes that we're working with, are now going to be very slightly different. They are going to be, they're not going to be split by the meeting points. They're going to be, we're going to like apply, we're going to apply the different there's 2 points, and we're going to make 2 boxes. That's still true. We still have 2 boxes. So we're going to say new forwards ROI. This is going to be our current ROI at the current IDX. How do we want to say this? Let forwards XY, forwards X, forwards Y file, we need that, is equal to the self forwards X forwards K. I think it's X minus K gives us Y. I think. There's somewhere we're doing this. X minus K. Yeah, okay. So this is the X value. Oh, and then there's like this like ROI fucking healing shit as well. Fuck me. Okay. I guess we'll split this out into a function so that we don't get like lost. What is this function going to be called? And is there like anything that kind of resembles this? Calc X, blah, blah, blah. Oh, I'm getting stuck. We just need to type something and then make progress. So we'll say function calc Y for... What are we even trying to do here? We're trying to like resolve this like X and K into a Y. So where does like forwards X value come from? He gets this like forwards value, and he doesn't seem to like, why doesn't he adjust it for the current ROI? Probably because it's like, you have like this whole area, and then we have like this sub-region that we're running in, and we're going forwards and backwards within this region, but the forwards and backwards will like line up. So we can treat this as 0, 0 until we're trying to split the next ROI. I see. That's why we do it that way. So at this point, forward X values are relative to ROI. Sure. Which means that we can make our new ROI in old ROI space and then convert it to like absolute space later. Sure. That seems maybe reasonable. I don't fucking know. I don't fucking know. So new forwards ROI rel current ROI is equal to a rectangle that takes the current ROI, which is self ROI, self current IDX, and he has left is current ROI left. We do this for right, top, bottom, yep. And what's actually happening here? So we want to limit the bottom right on the forwards ROI. We want to limit the bottom right to be where we were on the backwards path. So the right is going to be the backwards X val. Kind of like this shit. Yup. And bottom is going to be this shit. Yep. And then the backwards ROI is going to be like the same thing. Except he's going to keep the right and bottom. And adjust his top left. So we're going to do the same thing that we did here. But this is going to be left, and this is going to be top, and we're going to use the forwards X val instead. Okay. And then we now don't have like a single meeting point to store. I guess we just store both? Because at the end, we just return the meeting points. Maybe at the end, we return the ROIs instead of the meeting points, and then we can construct like new forwards pass algorithms just based off of those. So we'll say that we're going to return a vector of rectangles here. And here we say ROIs, and here we say ROIs. Okay, and we might need to like clone them. No, RO rect like this. Here we go. That makes it work out. So self ROIs here and self ROIs here. And then I think that we can just nuke this like meeting point thing. I think we just don't need to store those anymore. Okay. We don't do this anymore. And so we now say, here are our new ROIs. Okay. And let's just kind of like start slowly working through this and seeing what happens. Okay, so we don't have this like singular meeting point anymore. Fuck that noise. Do we still compile? No. At 556, we are trying to look at these meeting points, but now we need to say for ROI in ROIs. And so this is now going to be ROIs and ROIs len. Now we're no longer +1. We're making one algorithm per region of interest. And so now we're just saying that it goes what? Top, left, bottom, right. So ROI left, ROI bottom, ROI right. Okay. Yeah. No longer need to track the previous version, the previous XY, because like the whole information for this box is contained now. Do we compile? We do compile, and I wonder if with this I wonder if this works. Might not. Might. Okay. So let's try. So here they smack into each other. They are still overlapping, which seems like a bug. That's not what I expected. Oh, but here they're not. So that's a good sign. That's a really good sign. That's an improvement. So here, why? Oh, it's vertical overlaps. The two x values are the same, but the y values are not. And we're only switching on x value. And then here, these are ending up the same box, which is a problem. Okay, so how did we lost the same box exit condition somehow. I must have just deleted it without thinking. Yeah, we deleted this. So I guess we need to convert this exit condition to something else. Oopsies, what the fuck did I just do? Okay. So now it's if instead of its meeting point, it's now if the forwards are backwards ROIs equal to the same thing. Or if either is 0, which I think is the same. So I think we can maybe just do this. And here we say ROIs. I think that'll do it. Not really sure. I guess we'll find out. Yeah, okay. So we're back at it succeeding, but we're not seeing these lines drawn. We do need to see these lines here drawn somehow. And I would like to see these this Y overlap fix itself as well. Okay, so let's start with the drawing of the diagonals here. So it's when we generate our debug info for drawing. We construct Meeting points? What the fuck? Is this what we're using? So when we're backtracking, we get the debug info for each section individually. I see. Which is maybe fine. Maybe not. How do we want to draw this? How do we want to handle this? So here we look at each individual algo and we draw each box, which seems fair. But now we need a way to visualize the in-betweens. I guess we just draw the lines between their top left or bottom right and top left. So we'll call this like extra or connections, we'll call it, which is going to be a vector of pairs of points, I guess. I think. And then here we can say connections is going to be something like we're going to look at each of the algorithms that we're like currently backtracking and like look at them in windows. So we're going to say like for window in Windows, and then we're going to say connections push the window first things bottom right. And then the second thing's top left. Or something? I don't know. So this needs to be like something like this. Gross. They're saying that this doesn't have a left. Oh, because I used this comma there instead. And then here I can say connections like this. And here connections is going to be empty, probably, while we're snaking. And I guess for some reason he needs the type information here. What an ugly type, by the way. That should probably be cleaned up. So what is the type of this? This is a reference I64. Oh, because this is algo. Oops. That makes more sense. Which means that this doesn't need this type inference anymore. Okay, there we go. There we go. So now we just have to draw that thing so we can look at our diff viz. And when we're drawing our linear debug info, we can just say for connection in debug info connections, we draw some line. I guess. So we're gonna draw some sort of like painter line segment with our like color. I guess the color doesn't matter. I guess we'll just do green or something everywhere. So we can say our like stroke is equal to stroke. And then we change the color. I don't know. We'll use green for now. It's fine. Then we need to say our beginning position is going to be some sort of like conversion from connection 0, 0. This is going to be start x, start end x is going to be connection 1, 0. And we do the same thing for y. So these need to change to y's, and these need to change to 1s. And then we should be able to draw a line here. painter line segment, which is start eGUI pause to start x and x, or start y, I guess, to eGUI pause to end x and y. Okay. I think. And now if I render this, I hope that we see the lines between the boxes drawn. When we get to that end state. Okay, that's really good. So it's drawing these, which is great. And now we do have like one path drawn from the whole way. So that's a good sign of some form. And so now when we generate our final diff, probably our tests right now are just going to like shit themselves. For something's not compiling anymore, which is odd. Because we renamed something, that's fine. So probably all of our tests are going to shit themselves. No. They're not. Is this the right thing? Interesting. So that's actually just working. Are these using the new code? They are. Oh, but maybe they're not setting max memory. Okay, yeah. So here we need to set the maximum memory to like 50 or something. Like just make it small. Just to see what happens. 50 is still fine. What if we set it to 0? Do these tests still work? Yeah, they're still working. Okay. So it does look like this is behaving sanely. Can we maybe spiff 2 files and see if that looks sane? Yeah, it does look like this is still behaving okay. That's pretty cool. So we're going from 1, 2, 3, 4, 5, 6, 7, 8 to 4, 5, 6, 8, 1, 3, 2, and we are seeing this like thing, so I guess it's working. Can we try doing it on spiff GUI cargo lock and cargo lock 2? So in this scenario, maybe we do like Valgrind tool equals massive. I just want to see like the memory usage over time. So I want to see like with the old version, how much memory did we use? And with the new version, how much memory do we use? Is it like significantly better? So let's like diff these two guys, and we can say, I think we need massive visualizer. I think that's the guy. And so let's look at massive visualizer, and we must have some output here. No? Valgrind tool massive spiff GUI cargo lock 2. Okay. So is there no output here? What the fuck? Am I high? I feel like it's supposed to give me some output here. At least that's my memory. Valgrind. Massive. What the fuck? Valgrind help. Tool equals massive help. Is there not supposed to be like an output file here? Maybe like the threads are confusing it and it's not seeing any allocations or something. File. Massive out file. Output file name is usually massive.out. Okay, I guess we'll just manually put that there. I've never seen this before. Massive out file equals test massive. Like, bro. Maybe it's because there's no debug symbols. If I run target debug spiff GUI on cargo lock and cargo lock 2, well, it's taking a lot longer, which is a good sign, I guess. Over memory limit error. Cargo build. Is it because I didn't build spiff GUI after the new changes? Possible. And let's also make sure that our memory usage is sane. Yeah, why is this over memory limit being hit at line 669? Oh. Because I'm an idiot. I am an idiot. These guys are supposed to be using the forgetful version of the trace. And we had these kind of tagged in for debugging. So this should be forgetful here, and this should be forgetful down here. And let's run the diff visualizer just to like indicate what that's supposed to be doing. Let's try one more time here. So here, now what we should be seeing, yeah, okay. So now what we're seeing is like the forgetful version's running. So we're only tracing back like one iteration. Okay, so let's try that. First we'll cargo test just to make sure everything's happy. Okay, and let's cargo run or massive. What we were trying to cargo build. Do you code when you have a headache? Sometimes. Not a lot. I find it too hard to think. I also don't get headaches that often. Usually my headaches are like, I get like migraines, and when I get migraines, it's like, time to fucking hit the bed right now. Because if you just you just have to sleep it off. At least I have to just sleep it off. So for me, no, but I think everyone's mileage will vary. People will behave differently. Okay. So it looks like we have done something. He generated a diff. Great. And we can look at... Holy fuck. That's still a big-ass number. Oh, maybe that's 69 megs? Is that? Let's look at massive visualizer, massive out. Which one of these is newest? Massive visualizer. Okay. So looks like peak memory was 25 megabytes, which is still quite a lot. Quite a lot. But can we compare that to how it was before? So let's git add you, git commit dash m smiley face. And can we like maybe go back to master? Build. So we don't forget, 25 megs, 25 megs, 25 megs. And we want to run this same test where we look at this like cargo log file. And we have to be careful that we don't end up swapping and ooming and shit. So I'm just going to like spam this and watch this like memory usage number. Okay, so right, I forgot that there's a limit here. So we can say, hey, I'm going to limit you to like 500 megs. Okay. And then now we can see what his max was. So you say massive visualizer, massive out 67163. Okay. And his is 254 megs. Okay. So we did kind of reduce our memory usage by like a factor of 10, like one order of magnitude. That's significant, a lot better. Maybe not ideal. So I am still concerned about the like case where we end up using way too much. So maybe we should still fail if we fail to get under the memory limit. I think that's fair. It's just our memory limit will be much lower now. I think that's fair. And then we can always go back. We know that there's like better optimizations. We know that this isn't perfect. So we can always come back if this ends up being like a big major problem. So wherever we were like, hey, wink, wink, this is going to be like a soft limit, I'm going to say, fuck that. It's going to be a hard limit. Suggestion, I think we commented. Oh, we want to be at whip. There we go. Okay. So I think we made a constant max. Max? What? Oh, it's the wrong branch. It's viz, maybe? Yeah, here we go. So here, I guess we will calc full trace mem usage bytes. We are going to look at all of our ROIs. And ROIs map here sum. There we go. Let total mem usage is equal to this. And this needs to say iter here. And here we're going to call this a usize like this. And then we can say if our total mem usage is greater than the suggest or like requested. If it's greater, then we're going to have to like I guess this will return an error, I guess. Who calls this step? I need to think about this. How do we want to handle this? How do we want to handle this? Where does this error handling live? I think here we'll say over memory limit. And then we'll do this check from within. So here we'll say return snaking state response over memory limit. Great. Then he will say, hey, if we saw, we're going to match snaking state step now. And if we see snaking state response finished, ROIs, we're going to do the same thing we were doing before. Blomp, blomp. Yep. But if we saw snaking state response over memory limit, we're going to return something. And if we see snaking state response none, we are going to do nothing. So here, I guess we need some sort of like way to flag to our caller, which means that this guy shouldn't return a bool. He's going to call like a linear, he's going to return like a linear algo response. We'll call it. And he's going to say either I do nothing or over memory limit or finished. Yup. And so here he's going to say, hey, I'm over the memory limit. Response over memory limit. Yep. This guy's going to convert none to none. And here he's going to say linear algo response none, I guess. When does he decide he's finished? What is like the exit condition here? Oh, it's here in the backtracking. So here he's going to say linear algo response finished here, and here he's going to say linear algo response none. Okay. This isn't supposed to have an arrow. And now we have to look for callers of this guy and fix them. So he's going to say, well, blah, blah, blah. So when this guy returns over memory limit, if we call him again, that's kind of invalid, but I guess we'll live with that. So here we'll say if match loop. We're going to put this in the loop. We're going to say match algo step AB. And if we see linear algo response none, we do nothing. If we see finished, we break. And if we see over memory limit, we return over memory limit error. Oh, and he needs to know the required and maximum. So this is unknown. So I guess we need to propagate that info. Yeah, here we go. Required. Okay, which means that here we need to propagate that info as well. Which means here we need to say we required some amount. Which I guess is something like this. Look. Let required mem is equal to this thing, and then we like sum him, and then we put him in here. Sure. I think that's right. Required, and then we have whatever. What does this guy need? He needs maximum as well. There we go. All right. I still can't figure out the intuition when to use enums versus structs. Enums are for any case where you have like multiple states, in Rust at least, right? In other languages it's not the same, but in Rust these enums are like, hey, in two different conditions I'm gonna have two different sets of data. And so here I'm using it as like, hey, I'm going to like return either I'm like finished, I don't want you to do anything, or I have like some error with some state that I want you to look at. It's like a way of branching, where like so if you have like, I see this pattern in like I saw this pattern at work a lot and I hated it, where you'd have like struct, like my struct, and then you'd have like, you know, like data 1, which is like a vector, I don't know, and data 2, which is like a data, like some like ints or something, and then you say like bool, like should use data 1 as a bool, and so like then you would like check this and say like if this is true then I should use this one, otherwise I should use this one, and the like don't fuck it up, like this guy's invalid unless this bool is true. Enums are just a way to avoid that kind of like conditional, like, oh, this is only valid in some states and this is only valid in other states. Instead of like putting that with data, you can make it like with the type system like unavoidable, make it impossible to use wrong. Okay. So are we chilling now? Is that all the piping I need? Cargo run, cargo build. No, because in diff viz we need to adjust as well to use that enum instead of a so we can just say match x step self A, self B, and we have the same three cases that we just did on this other scenario here, so we'll copy paste them. And if we're finished, we'll say we're finished. If it's none, we do nothing. And if we're over the limit, I guess we just say self finished is equal to true or something as well. And maybe we log or something, but I don't really care right now. I don't care. Which probably means this guy's be public, to be honest. Because he's kind of like leaking out of the abstraction. Alright. So now build, everyone's happy, probably. And then we can run our spiff GUI. We can run it without Valgrind. And we kind of expect this guy to take like 25 megs now, so if we say like 10 here, we expect him to fail, but he's not. Oh, here we go. So he's saying this required 8 megabytes, which is over the maximum of 0. Okay, or 8,000 bytes. Oh, that's way better. Oh, interesting. So maybe that, like, oh, that's so much better. So that means whatever like that 25 megs we were seeing in Valgrind must have been from something else. We should look a little more closely at that. Because maybe that 25 megs is from, like, GUI rendering code or something. So let's close this now, and let's look at massive visualizer, and we have to look at the right number. 675595. And so here he's saying, hey, there's 25 megs here, but where does this come from? 6 megs from full Myers trace. Which is a lot less than, like, the limit that we calculated was 1. But is this from, like, what's happening here? Recompute diffs. So from this, like, linear diff step, this full Myers trace, someone is not respecting the limit then. Right? That must be what's happening. Full Myers trace 240, lib 242. That's here. Oh, so that's not helpful. Fuck. We wanted to look one layer up. 663 and 571. 571 is probably the interesting one. Fuck me. We just weren't thinking. Okay. So this is when we are finished. Oh, interesting. So it's when we say that we are finished in the snaking state, we are not handling that correctly. So here, we should only be returning finished when we're under the memory limit here, though, right? We're only returning if the required memory usage is underneath the max memory. So how are we getting, like, way more than max memory? You know? Oh, I'm an idiot. It's because the maximum memory was flagged high. Hold on. So because our maximum limit was 100, and so it allocated under as much as, like, it only split until it needed under 100. So what's the tool here? Valgrind, tool massive. Let's generate the diff again, but lower the limit by a lot. Okay, so what we should see here is if I type 1 here, and then close, and we look at this guy, we should see he spiked up a lot here for the first diff, but then later he didn't need, like, anything. So maybe if we set the default, that'll probably be more sane. So we'll look at somewhere we put 100 as the default, probably in spiff GUI options. I remember there being diff options. Maybe here, when we build this guy, we use max memory 100. So we'll set this to 1. Cargo build. And we should see the memory usage decrease by fuck ton. Wrong. Wait, what am I doing? That's the wrong command. I'm trying to Valgrind tool massive. Here we go. Generate the diff. Come on, baby. Come on, baby. Okay. So here we have 1 megabyte set, and if we look at the massive output now, 677353. Oh, much better. So here we still have our peak memory usage is 20 megabytes, but now hopefully it's not coming from. Yeah, it's not coming from our diff algorithm. It's just coming from like around, which is totally fine. Yeah, I'm happy with that. I'm happy with that. Sick. Sick. Okay, so now I think what probably makes sense here is to first let's like look for print lines and just kind of like nuke all of these annoying print lines because they're going to be a pain in the ass in a second. Okay. And let's go to spit, our git GUI, and let's update our dependency on our diff tool to use what we just changed. I think it's like this. Yeah. So I should be able to now say cargo run on this. And hopefully now we should be able to see like reasonable diffs in under a megabyte of memory usage. And we can kind of just like quickly take a glance here to see if they look sane. Okay, so we crashed. That's interesting. Did not find object ID for head. Oh, detached head. That's interesting. I've never seen, that's something that I've never seen before. Spit dot. Cargo run dot. Oh, it's because I clicked on the index maybe. Maybe that's a bug. So here, he still is saying that he needs a metric fuck ton of RAM. 1, 2, 3. Interesting. So why does this guy cause so much problems? Are they all like that? So 1 meg? Interesting. So this is saying this requires, what is this? 1, 2, 3, 4, 5, 6, 4 megs. So it'd be interesting to see how much of a difference that is from like the old way. So git diff, can I just stash this? Yeah, git stash and cargo run. Is he not rebuilding? Is that why? Uh, 1, 2, 3. Oh no, okay, so we have reduced down from like 26 megs down to 4, which isn't great, but it's not terrible. This guy needs 1, 2, 3, 4, 5, 6. This is 300 megs with the old way. And $91 now. That's still shit. Oh wait, was that 100? Yeah, it still needs 100 megs. Not great. Not great. But I guess better. Right, like the vast majorities are working under 10 megs. Maybe we just set 10 as our default for now. What are the cases where that's not working? Did we just fucking crash? What just happened? Oh, he just fell behind. Why is he falling so far behind? 1, 2, 3, 4. Is this 15? So maybe he's at like 30. I guess we just leave it at 100 for now. It's not the best. It doesn't feel like we've kind of fully solved the problem. I would like to know why. It would be interesting to like visualize some of these like failure cases here where it's like still requiring a lot of RAM and looking at like what is happening here. Is there a way to do that? You could. We could feed this into the visualizer somehow. So you could eat the you could pass in full files for A and B and just not try to render the labels in the diff visualizer. Seems maybe possible. Then the visualizer would have to break these guys up by lines. Do I want to do that right now is the question. We could try it. We could take a little look. Okay. So let's I guess first we can look at, so this is in this commit. There's a cargo lock change. So we could look at git show the last iteration's cargo lock, and we put this in spiff spit lock A, and we look at the current head's cargo lock and put that in spit lock B. Now I should be able to cargo run spiff GUI on spit lock A to spit lock B. And we should be able to reproduce the same problem here. And so this guy's saying the same thing, that he needs 91 megs. That memory viz is so much nicer than what I was playing around with to produce the HTML file output. You mean like the massive stuff? Yeah, it's super useful, super useful. Okay, so now what we want to do is we want to look at like a diff visualizer. And in here, we right now are saying, hey, feed us a bunch of integers as your A and B. But what if we then instead said, we'll take some paths to some files. Okay, and so we need to use std path buff. And I wonder if this is going to be a shit show. So A is equal to A next, or IT next here. And B is equal to next as well. These guys are going to be path buff options, I guess. Oh, oops. None is what right here. And maybe we write like into like this. And then here we say these guys are going to be option path buffs. Here we need to maybe like map x into or something. Like that. And then down here we need to like unwrap these guys. So let A equals sum A equals A, else return error A not provided. And we'll do the same for B. And then we're chilling. Okay. So now we need to parse these arguments in some way. So when we construct our diff algorithm, we're going to have to say let A is a string. It's going to be from args A. Std fs read A, this path. Yep. And then we're gonna have to like split him by lines. How do I guess this needs to be like unwrapped. Split. So I kind of want to like split by something like b is equal to n, new line. And then we want to like collect it into like a vector of strings. I don't know. Which he doesn't like. Because expected U8 found char. Oh, interesting. Okay. So he split at the byte character thing, blah, blah, blah. And now he's saying cannot make string from item of byte slice of U8. Okay. Sure, I don't care. Yeah, okay. So, yeah, and then we do the same for B. Then we use a.len and b.len here. And all of our diff algos need to be using these guys, who are using kind of like byte slices, which is kind of annoying. Maybe for now, even though this is like kind of shit, we'll do something like vec u8 here. And I think that actually we're going to need this to be we're going to need to like own this stuff outside here. So we're going to do vec u8 here and here. And then we're going to say let a is equal to whatever we were doing in that construct diff algo. We're just going to do this externally here. Yep. And then we do the same for B. And then this guy's going to take in A and B like this. Who's going to take in A, which is a reference to vec u8 or something. B, which is a byte slice of vec u8 or something. I don't know, man. We'll fucking figure it out. And then args.a. Everywhere we use args.a, this used to be like A, B, A, B, A, B. Okay. A, B. Okay. Oi, 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 oi. Map x2 vec or something. Map x2 vec. Okay, please, please. Please let me go. Okay. And then here, we're just not going to draw headers. Draw diagonals is expecting I32s here, but we can say, please give me slices of fucking anything. I don't give a fuck. But he needs to be partial EQ. Okay, that works. And it looks like everyone else is chilling. Maybe. So now we should be able to do diff viz, and we should be able to say, with A, it's spit lock A, and B is spit lock B, and now we should get like a really fucked up graph, and I just hope that this doesn't fucking crash me. Memory usage is going up by a lot, very fast. That's very scary. So how big are these guys? 105K. So why was I going into like the gigs of memory? That's really scary. Because if I my whole computer becomes like fucking usable and stream will die. So I just have to be like very careful about this. We could maybe run Valgrind tool massif on diff viz. And then we run a spit lock A, B, spit lock B, and just kind of see once this memory climb starts to become very scary. Ooh, over memory load error at main 200. Ah, so there I was on linear. Okay. So now we have to be careful here. We just keep monitoring. We spam space. Okay, he's climbing, he's climbing, he's climbing, he's climbing, he's climbing. Okay, I think that's enough. So get me out of here. 6, 8, 3, 6, 4, 3. Okay. Yeah, so what is happening here? Where is this coming from? Oh, interesting. It's coming from the GUI painter. Right, so there's just way too many fucking nodes, and so we're queuing up a bunch of paints. And then the GUI's like, ruh-roh, I don't know how to, like, I need to remember all of these draw calls, and these draw calls are just like, there's way too many. Fuck, man. I just want, like, it would be so nice to be able to, like, see why. Why? Okay, that's unfortunate. I feel like I have to think about it. I'm not really sure where I want to go next. Like, I don't really know if I want to really continue on with this, call it where, like, say it's good enough as it is. Try to, like, reduce it in some way. So, I'm going to think about it. Call it a day there. Thank you for watching, guys. I hope that this was still enjoyable. I know we didn't, like, it felt like we didn't really do a lot, but we did make some progress. If I get stash here, cargo run, this, like, old thing. We did get to the point where the splits, they are a little bit better now, so we are seeing some cases, I think, where these boxes are, like, reducing memory usage more than they were before. I would have liked to see more progress, but it's okay for now. So, calling it there. Not sure what we're going to be doing tomorrow. I'll have to think about it. Any idea what your next project will be? So I know that there's, like, still work that I want to do on the Git GUI. I know that there's some work I wanted to try in order, like, with tree sitter based diffing. I wanted to try that. I'm still working on this, like, terminal emulator, so we are going to jump back onto the terminal emulator at some point. That's the plan as of right now, at least. I have a list of other things that I, like, kind of want to work on too. So, like, in the backlog is, like, falling sand style game from, like, the 90s or from, like, the early 2000s. I want to, like, build, like, a WASM interpreter. I want to build, like, I want to try a compiler at some point. There's this, like, map project that I want to work on where, like, I want to, like, scrape transit data and try to see if I can do better than Google Maps in terms of, like, how am I supposed to bus around my city. There's lots of things that are, like, on the list, right? Lots of things. But I think the near future is more Git GUI and more terminal emulator. So if you like what you saw, there's a YouTube link in the Twitch description that shows it for some people. If it doesn't show up for you, it's the same tag, but just on YouTube. And there's, like, playlists of all the things that we've been working on. VODs go up there usually around, like, one day after stream. There's a GitHub link in the Twitch description. Again, if it's not there, GitHub is the same username where, like, code for these projects ends up. If you're watching on YouTube, there should be a Twitch link in the YouTube description. If you're online between the hours of 1 and 4, you might want to swing by, see if we're online, see what we're doing. Yeah, and we'll be back on tomorrow. I just have to figure out with what. Thanks for watching, guys. Catch you on the next one. Bye!